All right, let's go ahead and get started. I do want to welcome you to this second screencast for Unit 7. This is chemical reactions. In our last one, we took a look at 5 different types of chemical reactions. We started with synthesis, in which we put two things together to form one chemical, right? That was a synthesis reaction. Then we looked at decomposition reactions, in which we broke something down. We degraded some chemical into its components. So an example of that was an electrolysis, in which we took water and decomposed it into hydrogen and oxygen gas. So that was a decomposition reaction. Then we looked at single replacement reactions, reactions in which an element, maybe a metal, replaced a metal, or a nonmetal replaced a nonmetal. But it depended on something called the activity series that we're not too familiar with at this time, but we're going to become familiar with it pretty soon here. We looked then at double replacement reactions, in which we had two ionic compounds, both of which were aqueous, and we mixed them together, and in the process, if we formed a precipitate, then we had a chemical reaction. So that was a double replacement reaction, and we ended it up with the combustion reaction, in which we had a hydrocarbon, something composed of carbon and hydrogen. We call that an organic molecule, and we broke it into its component carbon dioxide and water. It burned in the presence of oxygen, you recall. And so we always have this for combustion, we always have the same products, CO2 and H2O. All right, what we want to talk now about is balancing chemical reactions. In order to balance chemical reactions effectively, we're going to need to understand something called the law of conservation of mass. So let's go back to John Dalton and what he had to say about atoms, right? What John Dalton said was that atoms could not be created, they couldn't be destroyed, they could only be rearranged. And this really is the basis for conservation of mass. It states again that matter can't be created and it can't be destroyed, and that every atom that has ever existed exists today. When chemical reactions occur, the atoms that make up molecules are simply transferred from one molecule to another, but the atoms themselves don't appear or disappear. In other words, matter is conserved, right? Matter is conserved. You can't create matter, you can't destroy matter, you can only rearrange it. And this is really the basis for chemical balancing or balancing of chemical reactions. When we write a chemical reaction, we use coefficients. We've already looked at these coefficients. We've seen them before. These were those numbers that appeared in front of chemicals in a chemical reaction that was balanced. We use coefficients to balance the number of atoms on the left and on the right hand side of the chemical reaction. So that's what we're going to do today. We're going to look at how to manipulate those coefficients to give us the right number of atoms on the left and the right. So let's take a look at an example. The following reaction is called a combustion reaction. We've looked at that. That was that fifth type of reaction type that we looked at. Notice that there are the same number of carbon, hydrogen, and oxygen atoms on the left, the reactant side, and on the right, the product side of the reaction. All right, so let's take a look at this reaction here. Here it is. It says the balancing of atoms is possible because coefficients are placed before specific reactants and products. A 2 is placed before the oxygen and the water in the following reactions to balance the atom. So let's take a look at this combustion reaction. We've got this molecule here that is called methane. CH4 is called methane. It's a hydrocarbon, hydrogen and carbon. A hydrocarbon molecule in the presence of oxygen burns, right? It burns to form CO2 and H2O, right? It forms carbon dioxide and water, right? So why the 2's? Why do we have to have a 2 coefficient here and a 2 coefficient here? Well, let's count up the atoms after we put the coefficients in front. Let's start with carbon. I've got a 2 in front of the, I've got a 1 in front of the carbon. If there's nothing there, it's understood to be a 1. So 1 carbon there, 1 carbon there. So on both reactant and product side of this reaction, there's a 1, right? So carbon is balanced. Fantastic. Let's go on to hydrogen. How many hydrogens? 4 hydrogens on this side. How many on this side? Here's where that 2 comes in. 2 times 2 is what? 4. So we've got 4 hydrogens on the left, 4 hydrogens on the right. We're balanced. Finally, oxygen. 2 times 2, 4. 4 oxygens on the left. How many on the right? 2 here and 2 more here. 2 plus 2, 4. 4 oxygens on the left, 4 oxygens on the right. This chemical reaction is balanced, right? And we've already said that if there's no coefficient in front of a compound, it's assumed that the coefficient is 1. In balancing chemical reactions, it's okay to change the coefficient. You can change the coefficient, but it's not okay to change the subscript because that would change the identity of the compound. Let's just say that if in my manipulation, I said, okay, I need more hydrogens on this side. I'm going to change this to a 3. Can't do that. You can't change H2O. H2O is water. It's 2 hydrogens to 1 oxygen. You can't just arbitrarily say it's going to be 3 because I need to be able to balance this equation. Water is H2O. Subscripts can't change, only coefficients. Keep that in mind, okay? All right. After the coefficients are placed, there is 1 carbon on each side of this reaction, 4 hydrogens on each side, and 4 oxygens on each side. We're balanced. A chemical equation is balanced when the same number of each kind of atoms appears on the reactants and the product side. Okay, I think we've got that now. All right, let's take a look at a couple of different reactions here. Here are 2 more balanced reactions. Let's start by asking this question, though, before we balance it and verify that they're balanced. What kind of reaction is this? This first one, what kind of reaction? We got H2, 2H2 plus O2 yields 2H2, 2H2O. We've talked about types of chemical reactions. What type is this? It's a synthesis reaction, right? We're putting 2 things together to form one. This is a synthesis reaction. Let's verify that it's balanced. We've got 4 hydrogens over here. We've got 4 hydrogens over here. We've got 2 oxygens on the left. We've got 2 oxygens on the right. This one's balanced. The synthesis reaction is balanced. Let's take a look at the next one. We've got tin carbonate, right? Tin carbonate becoming tin oxide and 2CO2. What kind of a reaction is this one? That's right. It's a decomposition reaction, isn't it? We're breaking something down. That's a decomposition reaction. 1 tin on the left, 1 tin on the right. It's balanced. Carbon. 2 carbons on the left, 2 carbons on the right. It's balanced. Oxygen. 6 on this side. How many on this side? Well, 2 here, but 4 there. It's balanced. Once again, notice that they're the same number and types of atoms on the left and the right-hand side of these reactions. So hopefully you now know, you can at least verify that a chemical reaction has occurred. Now what I want to do is I want to take a shot at balancing themselves. I want to show you a technique that I use, and it doesn't work every time, but it's been pretty effective for me, and so hopefully it'll work for you. Okay, let's make this just a little bit bigger here so we can see this just a bit bigger. All right, there we go. Okay, let's take a look at this first one. We're going to balance this chemical reaction. How do we do that? Well, what we're going to do is this. This is the technique I'm going to show you. See if it works for you. What I like to do is I'm going to put a 1 here, a 1 there, a 1 there, and a 1 just like that. All right? Now I'm going to have an eraser handy because I know full well that some of those ones, probably maybe more than one, is going to disappear. It's going to have to be changed. But I have a basis. I have a starting point to start with, right? So what I'm going to do now is I'm going to go from left to right on my, as I'm reading a sentence in a book, right? I'm going to go left to right. And I'm going to ensure from left to right that the atoms are balanced. Let's take a look at sodium. How many sodiums do I have on the left? 1. How many on the right? 2. There are 2 right now. I have to fix that. So I'm going to fix that first by changing this 1 to a 2. Now notice sodium is fixed. 2 sodiums on the left, 2 sodiums to the right. Now what I'm going to do is I'm going to go to the next element, which is a nitrogen. How many nitrogens do I have on the left? Well, 2 times 1 is 2. How many nitrogens do I have over here? 1 times 2 is 2 times 1 is 2. 2 nitrogens on the left. So that's looking good so far. Now let's start all over. That's what we're going to do. We're going to check and then start all over. 2 sodiums on the left, because if I change something, it may change something that I had previously fixed, right? So I may have to fix it again. So 2 sodiums on the left, 2 sodiums on the right, 2 nitrogens on the left, 2 nitrogens on the right. Looks good for nitrogen. Let's go now to oxygen, right? Oxygen is the next one in the line. How many oxygens do I have on the left? Well, I've got 2 times 3, that's 6 oxygens over here, plus 1 more, that's 7 oxygens there. Let's take a look at this side. I've got 1 times 3 times 2, that's 6 oxygens on here, and 1 more. Oxygen looks balanced. Now let's just do lead. Lead has 1 on this side and 1 on this side. So let's just check. Do one final check left to right. We have 2 sodiums here. We've got 2 sodiums here. We've got 2 nitrogens here. We've got how many nitrogens on the other side? We've got 2 nitrogens over here. We've got 6 oxygens over here. How many? Actually, we've got 7 oxygens over here. 6 plus 1 is 7. We've got 7 oxygens over here. That looks good. 1 lead, 1 lead. We're in very good shape here. All right? Okay, so it's balanced. Let's try another one. 1, 1, 1, 1. Make sure you have a good eraser because those may have to go away. We'll see. How many silvers do I have on the left? Right? 1. How many do I have on the right? 2. So I'm going to have to change this, right, to a 2, just like that. Now remember, the system doesn't work every time. You have to think, you have to modify the system that I'm showing you to get a balance on the left and the right. Okay? So 2 silvers on the left, 2 silvers on the right. Let's go to iodine. How many iodines do I have on the left? Well, I have 2 iodines on the left, but I have 3 on the right. Now, this is going to pose a little bit of a problem because of the fact that 2 and 3 are not multiples of each other, right? So here's what I'm going to do. I'm going to change this number. I have to play. This is going to cause a complication here, but I think I can fix this. I'm going to say 2 times 3 is 6, and then on this side, I'm going to put a 6 right here. Okay? So I'm going to put a 6 right there, just like that. All right? So now iodine is fixed. Now let's go back. Silver. I have 6 here. That obviously threw the silver off, so I have to fix that because I got a 2 right here. So what I'm going to do is I'm going to change this to a 3, just like that. Now I got 6 silvers on the left. I've got 6 silvers on the right. How many iodines do I have on the left now? I've got 6 iodines on the left. 2 times 3, I've got 6 iodines on the right. We're reading like we're reading a sentence in the book, left to right. Fix it left to right. How many irons do I have over here? I have 1 times 2, 2. 2 irons here. How many irons do I have here? I have 2. So irons look okay. How many carbons do I have on this side? 1 times 1 is 1. How many carbons do I have over here? I'm sorry, it's not 1 times 1. There's a 3 right here. 1 times 3 is 3. How many carbons do I have over here? 3 times 3, or 3 times 1 rather, is 3. Oxygens, 3 times 3 is 9, times 1 is 9. How many oxygens do I have over here? 3 times 3, 9. Let's check. 6 silvers, 6 silvers. 6 iodines, 2 times 3, 6 iodines. 2 irons, how many irons over here? 2 irons. How many carbons? 3 carbons over here. I've got 3 carbons over here. How many oxygens? 9 here, 3 times 3, 9 there. This reaction, my friends, is balanced, right? Let's try one more. 1, 1, 1, 1. Have your eraser handy. How many carbons on the left? 2. How many on the right? 1. Fix it. Erase. Put a 2 right there. Okay? Start all over. 2 carbons on the left, 2 carbons on the right. Move left to right. How many hydrogens here? 4. How many hydrogens over here? Only 2. Fix it. Make this a what? 2 times 2 is 4. Start all over. 2 carbons here, 2 carbons there. 4 hydrogens there, 4 hydrogens there. How many oxygens? 2 here, 2 here. That's 4 oxygens over here. We've got, how many over here? We've got 4. We've got 2 here. That's 6. This is what we're going to change right here. We've got, one more time, we've got how many oxygens on the left? We've got 2 times 2 is 4 plus 2, that's 6. Now right here we have 1 times 2, we have 2 oxygens right there. I don't want to change that 1. What I'm going to change is this right here. I'm going to make this into a 2. Now I've got 2 oxygens on the left, 4 oxygens, 2 plus 4 is 6 oxygens on the left. I've got 4 plus 2, that's 6 oxygens on the right. Let's check everything. Ready? 2 carbons on the left, 2 carbons on the right. 4 hydrogens on the left, 4 hydrogens on the right. 2 oxygens, 4 more oxygens, 6 oxygens on the left, 4 oxygens plus 2, that is 6 oxygens on the right. Folks, that's the technique that I use for balancing chemical reactions. It doesn't work every time and it doesn't work for everyone, but it works for me most of the time. I hope it works for you. Folks, that'll do it for this one. I'll see you on the next one. Thanks. Bye-bye.